Hello all. So last time we looked at the unit rate as the scale factor. Now we're going to be computing actual lengths from a scale drawing. So how can we use the scale factor to write an equation relating the scale drawing lengths to the actual length? So the scale factor is the constant of proportionality, or K, in the equation. So we have y equals K times x. So the constant times the original would equal the actual length, or here we can find what the scale is, like the scale drawing, which would be the final divided by k, or if we know what the scale and the actual is, we can find what k is. Okay, so it's the ratio of drawing length to actual length. So we have Vincent. He proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. So we want to find out if this lot is big enough based on Vincent's idea. So 1 inch on the drawing corresponds to 15 feet of actual length. So the dimensions of the scale are 1 2/3 inches by 2 inches. So basically this is going to be our constant, okay? So then to find our length, we're going to take 1 2/3 times 15 and 2 times 15. So we find out we have 25 by 30. Does that fit on the 25 by 75? Yes, it does. Okay. Here we have another one. We're looking at a garden. So pretend there's lots of flowers and veggies and everything in here. So the scale is 1 centimeter for every 20 meters. And 8 units is represented by centimeters. So each one of these is 1 centimeter by 1 centimeter. So each little square is 1. So we want to find the actual length and width of the garden based upon the given drawing. So here we have our drawing, which is x, the scale of 1 centimeter, the length is 8 centimeters, and the width is 4 centimeters. And the scale is 20 meters, because 1 centimeter is every 20 meters, or 2,000 centimeters. So we're looking to find the length and the width. So we take 8 times 20, we get 160 meters, or we could take 8 times 2,000 and get 16,000 centimeters also. Same with the width. 4 times 20 is 80 meters, or 8,000 centimeters. Okay? And then that's how we find it. So 2 methods to find the answers. One is using the given scale, 1 centimeter of scale for 20 meters actually, so that's what we did. K equals 20, so the actual length, y equals 20x, or y equals 20 times 8 for the length, and then 20 times 4 for the width. Or we can use the scale factor. So 1 centimeter of scale for 2,000 centimeters, so then in this case, K would be 2,000, 2,000x, so 2,000 times 8, 2,000 times 4. Okay? So you're going to work on this one on your own. A graphic designer is creating an ad for a tablet. When you're ready, hit play to see the answer. So a graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale corresponds to 1 inch on the actual advertisement. What will be the length of the tablet on the advertisement? So we have 1 1/8 inches by 1 1/4 inches. So K equals 4, 1 divided by 0.25. So y equals 4x. So the length is y equals 4 times 1.25, which is 5 inches. And the width, 4 times 1.125, or 1 1/8, equals 4.5. So it'll be 4.5 by 5 inches. So just like yesterday, you're going to complete the questions on Edmodo for this lesson. If you have any questions, let me know.